That's why they're branded. That's why they're branded with Sauce Labs, but there is no intention to sell the company where I work on. It's just that I was using the same slide template for other thing, and then I just reuse that for this presentation. Yeah, as Tom already said, I am part of the Selenium team. I also work at Sauce Labs. I am one of the open source engineers we have there. I do a bit of everything at Sauce and also a bit of everything in the Selenium project. And today I want to focus this conversation because I hope we have like this being two ways, not just me talking to you, on testing frameworks featuring Selenide. Before going into the detail of why Selenide, why am I talking about Selenide, I just want to talk briefly about, testing framework features. Because when you want to do testing, you need a few things that are usable for you, a few features that are ready to use for you to do actual proper testing. So sometimes you need, so this list is not complete. It might be obviously incomplete. There might be things that you want to add yourself. But for example, if you want to do testing, you obviously need assertions. You need to be able to do testing in different browsers. You need to have a framework that helps you potentially to do mobile testing. You need a framework that helps you to do, for example, real devices and mobile and virtual devices. You need a framework that helps you get reports out of the box. And if you invest your time doing all of that, then you might actually be not providing great value to your team. So that's why you bring and you get to the point where you start considering if you should build your own framework, or maybe you should look for a framework that is already built. So maybe if you want to write in the chat what makes sense for you, like just like build your own or use open source. Like what would you do if you had a chance to start over? Would you build your would you build your own framework, or would you find some that is already done in open source? Maybe like a few, if you can just write, I will build my own, or I would look for something that is already done. Okay, a lot of participation. Okay, one message is coming up. Yeah, so Nikki is telling us open source. So how much time? Let's say that you have, I don't know, 1 month. What would you do? So in my opinion, what I like to usually do, and it doesn't matter if it has to be for testing or for development or maybe just do a presentation. I mean, I usually like to use something that is already done. Um, it happens very often that you find something that looks good, but it's not doing everything that you have to do, right? And then what you do is you get that tool that has a lot of features you want, and you find a way to add what is missing. So it's the typical, I have something that does 90% of what I want, and then I add the remaining 10%. So it's a bit of a mix of using something open source, and then you add what you need to actually have the full thing working for you. And I have been at companies where they find something that is working 90%, but then they decide to do everything from scratch. And this is not only applying to test frameworks, this applies to CI/CD systems. This applies to many different contexts. So I really believe in the power of open source, and then mixing that with your own needs is it's a powerful combination. But then it comes to the point how to choose a framework, right? Like what are the things I should take into account? And I've been trying to build, how could I say that, like a mind analysis, like a way to walk through the different aspects you have to think about. And then a few months ago, I bumped into this blog post from the Chrome DevTools team. The Chrome DevTools team have been working extensively into building a new standard for web automation, call it WebDriver by Die. And along that journey, they built a blog post that is, I mean, in like what? I mean, 10 minutes, you will get the whole history of testing frameworks that we have had in the last 20 years. So I'm going to summarize this for you in the next 5 minutes or less. So you can see the URL at the bottom, but I'm going to summarize that for you. So 20 years ago, 2004, so this year is the anniversary of Selenium. Selenium was created. And the first version of Selenium was injecting JavaScript inside the browser. If you think about tools like Cypress, that's how they work today. Most of the thing that Cypress does, it's how Selenium was working 20 years ago. It has more features. It's way nicer to use, of course, because tools have evolved. But conceptually, the same way Cypress does things today is the way how Selenium was working 20 years ago. Then we moved to Selenium WebDriver. That was when Simon developed this WebDriver API. And 2018, it became a standard where all browsers are adopting this way of automatic browsers. So then the question is Selenium WebDriver a test framework? What do you all think? Please just write yes or no in the meeting chat. There is a no. It is not. So someone said yes. I think it was Thanos. But most of you said no. And in the interest of time, then I'm just going to go with that. Like, it is not a testing framework. Selenium is a browser automation tool, so it's a way to automate browsers, but it lacks many of the features that a framework has, which is like, assertions, mobile testing out of the box, things like that. And then we can think that Selenium is not the only tool that does browser automation. There is a whole ecosystem called WebDriver. And this is because there is at the bottom a specification written that says how to automate web browsers. And then Google went there, Microsoft went there, Mozilla and Apple went there, and they implemented, and that's how you can automate cross browsers in your automation. So you can automate Safari, Chrome, Edge, and so on, and Firefox. So that was implemented. And on top of that, there is an implementation that is very famous called Selenium WebDriver. And on top of that, there are so many different testing frameworks. So you have Nightwatch, you have the implementation of Appium that is not a testing framework, but it's an extension of Selenium for mobile. You also have things like Water in Ruby. You have Selenide, which is a topic that we're going to discuss today. You have Atara, which is a framework in C#. So that's the whole context I'm trying to share. There is a layer of things that we are going to use today, that we're going to explore, and that's why we're going to jump into this topic. So Selenium is not the only implementation that you have out there. You have WebDriver.io, that is an implementation of WebDriver plus a testing framework all in one. And it also does mobile, and it's really, really good. On top of that, you have Serenity.js. Serenity.js is also a type of BDD framework that can use under the hood WebDriver.io, but also it could use something like Cypress or Playwright. So there are many, many, many ways to abstract the levels of implementation you use to automate browsers. And if you jump into the PHP ecosystem, then yeah, you have an implementation of WebDriver for PHP because, before JavaScript was big, PHP was the language being used to do websites, web pages. And on top of that, you have things like Laravel or Panther, which are testing frameworks to do browser automation in PHP. So there is, the world is huge. It's not just Selenium, it's not just Cypress, and it's not just Playwright. There are so many things out there that are useful, and the important thing is your context to see what makes sense for you. The world decided that JavaScript was going to be the tool, the language we were going to use to write web applications. And that's why we started seeing so many different frameworks out there. 2011, Web.io, then Appium, then you have Protractor in 2013, that it's already deprecated. And a small parenthesis, that's my concern with Cypress and Playwright. Like, at that moment, Google decided to create a testing framework. And over time, they said, we're not going to maintain this anymore. And all the users just had to find a way to run away. Why? Because this was owned by a single company. There was no open governance. There was no way to take that framework out of it and keep developing. So that's my concern with the tools that we have today, like Playwright or Cypress. I think they're great tools. They're super nice to use. But my concern is that they are so closed that if something goes wrong, many people will end up with a way of no escape. But moving forward, so we have Nightwatch, we have Test Cafe, Cypress, Puppeteer, and Playwright today. And then we can group these frameworks into different segments. So there is an approach to do automation using web APIs and Node.js processes, which is what Cypress and Test Cafe uses. Actually, Cypress mixes a bit of both. Cypress is doing a bit of CDP and a bit of, and most of the things via web APIs and Node.js. And you have all the section of low-level interactions, which is WebDriver and CDP. There has been recently a discussion of how can these frameworks make tests less flaky or more flaky? And people were saying that Cypress, for example, is helping tests be completely less flaky or not flaky at all. And in part, that is true, but it's true for the wrong reason. So for example, when you inject JavaScript in the browser has an event loop, and it starts executing events every time, well, it loops. So when the browser is looping and then it reaches your test, executes that line of code, and while that line of code is being executed, your web application is halted. So that's why you get the impression that the application is actually behaving better, because there is something holding the application, so your line of code is being executed. That might be nice, but it's also creating side effects, like service workers might get out of sync, things like a real user is not actually pausing your application to do a click. So that's the main difference between these high-level applications, these high-level automation approaches, and the low-level ones. To more detail, this is how WebDriver works. There is something like Chrome driver, Gecko driver, and etc. executing instructions in the browser. On the other side, you have CDP that actually creates a direct connection to the browser via WebSockets. And it's a good moment to explain what low-level controls are, right? Oh, there is a poll, so I'm gonna pause myself. Yeah, so that's an interesting thing, because I mean, I'm a person who is advocating for Selenium, for WebDriver, for the open web. So I guess if you ask a question like this one in a talk I'm giving, in this context, most people are going to say something like WebDriver or Web.io, and very few people about Cypress and Playwright. But if a Playwright ambassador or a Cypress ambassador makes the question in LinkedIn, then the results are different. So we have a bit of bias here, no? So we have to be also aware of that there is bias in our context. And I am advocating for Selenium for WebDriver, but this doesn't mean that Cypress or Playwright, they don't have good features, and they are good for some contexts as well. Do we want to wait more for the poll, or should we move forward? Share results. Okay, yeah, we're done with the poll. I'm happy to see that most of you trust WebDriver. And do you want to share them now, Petros? Okay, good. So what are low-level controls? The thing is that the web has evolved immensely in the last 5 to 10 years. And it's not enough to be able to click and wait for like a text to show up. We're now interested in the JavaScript console, in the console logs, in the network requests that the browser is doing. So there are many more different aspects that are interesting for us as testers than just like seeing the UI. So all these things that are part of the low-level controls concept are ways to help us get more information from the browser, from the web application that we are testing, and then we can do more assertions. Because you could have a website that everything looks fine, but when you open the developer tools, you will see many, many errors in the console. And this is because probably there is, I don't know, like some JavaScript is missing, or some WebSocket is not closing properly. And through these low-level controls, we can actually do more low-level assertions without the need of having extra tools for that. So to round up this section, this is where WebDriver bidirectional comes into play. So the folks from Google are investing a lot into this. And the idea is that we're going to have a way to do, I shouldn't say it like this, but it's the best way to explain it, I would say. It's a way to do CDP in a standard way across all browsers. So you're going to be able to do all these things in Safari, in Firefox, and Chrome, and Edge, and all the other browsers. And the good thing is that this is a tool that will help us automate every single other browser. And for example, the advantage of this is that you have Puppeteer, that it's only able to automate Chromium browsers, so Chrome and Edge. Now they actually switch Puppeteer to use BiDi. And Puppeteer is now able to automate Firefox and Chrome and Edge. And with that, they're going to be able to be in the future, be able to automate Safari as well. So if we extend the ecosystem, you will see here on the bottom right that now there is someone else part of the WebDriver family. And that's why we have now the BiDi implementation that is already happening. And we see how the family is growing, basically. Some of us in the projects and in the ecosystem, we are making the prediction that Playwright will end up there, because Playwright needs to do a lot of things to work properly in every single browser. They need to patch Firefox, they need to patch WebKit, which is not the real Safari. So we believe that all these features that we're implementing as an ecosystem, they will be helpful for Playwright, and then we're going to come closer and we're going to end up collaborating to actually provide a better testing ecosystem for everyone. So this was the very long introduction, and that's why I want to introduce to you all Selenide. So Selenide is a tool, is a framework built on top of Selenium. And the premise that Selenide has is that you can write tests that are very, very easy to understand. The framework has a very, very simple, concise, and simple API. You need Java 17 to actually use it. I'm highlighting this because the minimum version that Selenium requires is Java 11, but we're going to change that pretty soon, maybe in 6 months, I would say. And the idea is that you're going to have stable tests because it has many of the features that you're implementing on your own when you don't have a framework, they are being implemented directly in Selenide. It was created by Andre, and it's good to mention that several parts of the following slides were actually built by Andre, and that is just to mention that we collaborate closely. He's part of the Selenium ecosystem. We go and help him with Selenide. We do things together, and that's the point of an ecosystem, to help each other to move forward. So Selenide has a bunch of advantages. There is automatic waiting. The code is much easier to read because a lot of the boilerplate code is already part of Selenide. There is an assertion library already in the framework, so you don't need to import more things. And there are many ways to test different common scenarios. So like it has utilities to test a PDF. It has different ways to assert text. It has a way to download files. It's very, very nice because it actually abstracts a lot of the complexity of assertions for you. So this is a typical, very simple UI test in Selenide. You first focus that you're opening a URL. So you have to notice here that we're not doing any driver equals remote web driver or driver equals, I don't know, Firefox driver. You just start because Selenide is taking care of all that in the background. You reduce the length of the code you're writing because you have the $sign operator, which is very common since jQuery. Web.io uses a similar approach, and many new frameworks and popular frameworks use this approach, where you declare this $sign as a way to declare the locator, and right away you can start interacting with the element. And when you're done and when you set a value, you can actually press enter. So there are many ways to chain commands in a simple way. And even if you're not using page objects yet, or a way to abstract this logic, it's much easier to understand what is happening here because you are setting a value, and after the value is set, you're actually pressing enter. So those things are it's what they call syntactic sugar, and makes the test much easier to understand. And then in the final line, we're actually doing a location of an element, but also we're doing an assertion on the same line. So this makes things much easier to read, and much easier to maintain, to be honest. With this, we start with one of the main objectives of Selenide, which is to reduce the boilerplate code. Because when you have a consent... So there was a question, sorry. Because when you have a syntax that is pretty simple, then the amount of lines of code and the length of the lines of code is going to be shorter, and that makes code more readable. So for example, in Selenium, you do this to select the H1 element, and in Selenide, you just do H1, right? It's very, very simple. In Selenium, you do something like this to assert that an element is displayed. But in Selenide, you just say the element should be visible. It's also a way how you express yourself in English, right? Because the is displayed is something that is extremely common and embedded into Selenium. But when you're talking in English, you would most likely use the word visible. It's something that the eye can see. And that's a way to write tests in a more natural way, in a language that is more understandable. Then, yeah, you have something like, I mean, can you guess what this code is trying to do? Like if you just read it, it will take a while. It will take a few seconds to understand that, okay, you're finding an element, and then, oh, okay, if you find the element, this means that it's wrong. So, okay, so the element should not exist. So what I'm trying to do here is to say that the element should not exist. So all this boilerplate code just goes away, and Selenide helps you to have something much more understandable. It also has something that people have been asking in Selenium for a long time, automatic waiting. And when people have made these comparisons between Playwright and Selenide and Selenium and Cypress, the comparison should have been Playwright versus Selenide or Cypress versus Selenide, never against Selenium. But yeah, we cannot change the past. So in weights, when you're doing weights, you have the implicit weight in Selenium that it's not ideal because the weight is happening actually in the browser. So you have little control over it, and you just have to wait until it is done, or maybe it explodes, and you have no control over that weight. You cannot cancel it, you cannot pause it, and you're just on the other side waiting for things to be done. You have also other types of weight in Selenium, in Java, that is going to tell you, okay, the element that is located by this tag, the H1, wait 5 seconds until it's visible, right? It's a very long line to say, I just need to have this element visible. In Selenide, you would say, this element should be visible. So we should try to avoid implicit waits. This one is very verbose. It's hard to maintain. And yeah, this one is perfect. I think I like it very much. It's very simple, easy to read. And then you can extend this pattern to many different other aspects. Like you want something to be visible, you want something to have a given text, you want to have something selected or not selected, or you want to have something to be not present or disappear. By default, all these should methods wait up to 4 seconds, but you can always configure them with a flag. And this brings an interesting question. Because when we see other frameworks like, I don't know, like Cypress or other ones that have like an automatic waiting, that's what they do internally. They have like a pre-configured wait up to 4 or 5 seconds, and you can override that. But your impression is that it's waiting for you automatically. And this is what Selenide is doing. It's the same thing. We just have never had the opportunity to actually promote this more widely. So let's talk about locators. There is a diverse way to find elements in Selenium and therefore in Selenide. So the easiest way is to always use something like the CSS locator. It's much easier, but also you can translate things to have the by element or the by class help you to locator in a more understandable way, because there might be a situation where we don't understand exactly what the CSS locator is looking for. For example, in the first line, we're looking for an ID, but you can also go that way. And you can also do it in different other ways. So what I'm trying to point here is that even though Selenide recommends you to use CSS locators, you can also translate them into a more friendly and visible way if that's what you're looking for. But that's not the only way to do it. When you have a web element, there might be more ways to locate it. So you could actually find the read-only element. You can find the title, the value. Many people like to use data test ID. I think it's a good approach. I have seen recently that some people don't like the approach. Anyway, it's always an opinion. But the point here is that you can have an element like this button where you have a data test ID, and then you can create a locator that follows that pattern with a very simple line that calls that element without the need of actually extending to match the framework. So let's talk about reporting. And I think, yeah, I have like 10 slides more. They are all very like the previous ones. A small parenthesis, when I was going through, when I was exploring Selenide, it has so many features that I couldn't really decide what to put. I was already reaching to the like 70 slides, so I just cut back a lot. And I think we're just gonna give you an overview of Selenide. And maybe if you're interested in more, we can do another talk, or we can even bring Andre and he can share more with us. So reporting. One of the cool things that I found about Selenide is that when there is a failing test, like in this case, it gives you very useful information. So for example, in this case, it's telling us that the element is not having the text error, right? But in addition, it's also showing us the element. So what is the information that the element has? So the whole HTML tag is going to be shown in the error, so you can actually double check what is going on without the need to go and maybe check a screenshot, or maybe, I don't know, like go to the web application that is deployed. So that is actually saving you time from, like it helps you to be a faster debugger. And if you need more confirmation, this is really, really nice. Selenide, when there's a failing test, it saves a screenshot for you, and it also saves the HTML page for you. So you can go and confirm that and see that what the failure is. I've been chatting with Andre, and they are considering to save also the CSS files, so you can actually see the page, how the way it was displayed when you were gonna do the assertion. So that might come in future releases. Then you have things like a profiler. If you just annotate your class with the text report extension, you might be interested to know. So let's imagine a scenario. Sorry. So the scenario might be that your tests are now slowing down for some reason, and you need to analyze them, and you need to understand what is getting slow, because that could help you diagnose what is going wrong with the application, or maybe what is going wrong with your test framework. So if you annotate your class with the test report extension, and that's it, you don't need to do anything else, you will get this beautiful markdown table that tells you how long each command took and if it failed or if it passed. And I think this is super useful because sometimes you can actually do some tests in the way that maybe a locator is faster than other one, maybe a different way of changing the flow to test something and get the same result. Maybe you can compare which browser is going faster than the other one. There are different ways to use this information, but this is very helpful to understand where your test is getting stuck. I wouldn't recommend it to use it always, but if you have a scenario where you see that things are slowing down, it's a good fit to understand better what is going on. Selenide has natural integration with Allure. You just need to add the dependency in your POM file or in your Gradle build file. And before everything starts, before every test starts, then you can add the listener of the Allure Selenide integration. And then you end up, I mean, you can configure where the test report is going to end up, but you get things like this. So you will get all the execution steps of the test. And if something failed, you will get a screenshot and the page source as well. So this is extremely useful. Andre and I, we have different opinions about test reports. He thinks that the default setting, which is no reports at all, just using the JUnit report is enough, because he thinks that like these reports are more like for managers, like managers want to see test suites getting executed or not. I differ. I think it's quite nice to understand better how my test suite is going. If I can have something that is good looking and like easy to read and understand, I prefer to have a tool that shows me clearly how my tests are doing. So I am pro to use this type of tools. And a few more things before starting to wrap up. I saw recently one of these, like live streams. Somebody was interviewing, I think it was a Playwright ambassador or something like that. And they were saying that Playwright is faster than, I think, WebRIO or something like that, or Selenium, I don't know, because it runs tests in parallel by default. And of course, like everything is faster because if like most of the testing frameworks that you get out of the box, they run tests in sequence. So they are not running in parallel. Selenide does the opposite. They run tests in parallel by default. So if you write two tests in the same class, they will be executed in parallel. And that might give you the impression that Selenide is faster than Selenium itself because it's running tests in parallel. But that's where your testing expertise, your understanding of the tools, your understanding of the ecosystem plays into. And you will see, yeah, Selenide is faster because it's running tests in parallel by default. That's the only reason why it's faster. So this is a nice feature because it just gives you the impression, but that's why. So you don't need to do anything. It's just working out of the box. You can tweak it, you can improve the configuration, but it's something that is quite nice. Selenide has mobile support out of the box. Um, there are plenty of examples. There are plenty of instructions how to enable that. And it's really, really good because in the JavaScript world, I think this is kind of solved because if you use WebDriver.io, then you will get support for browsers, desktop, and mobile devices. And it just works out of the box. In the Java world, this is not so simple because if you start mixing in the same dependency file, if you put Selenium and you put Appium, sometimes we haven't had the best communication between Selenium and Appium. And it has happened that sometimes we do something in Selenium and we break something in Appium. So we have to coordinate often those things. Selenide just removes that for you. If you add a dependency and you want to start doing mobile testing, it's there for you. So there is no need to configure dependencies. You just add Selenide and everything is there working for you. And a small slide that this is coming from Andre, and I put it there because I agree on most of the things. I think in all things. If you think about Playwright, I will put it for now as a positive thing that is driven by Microsoft, and this means that they are forced to have very good documentation. They're forced to have like very good demos. They need to have good marketing. They need to have advertisement. They are actually trying to monetize their service now with the Playwright Cloud. And in general, there is a team with very good budget to work on Playwright. And this is positive because either if they're not like playing nicely with the standards ecosystem, I think having a tool that is helpful for testing, it's already a big benefit. It doesn't matter what the tool is. So this is positive. But there are many downsides. So when you work alone, you can go faster, right? Because but you have like some limitations. You can do only local runs, and if you want to do like remote execution, then you need to have something like Selenium Grid, for example. You need to plug Selenium Grid, or you need to pay a cloud service like Sauce Labs. That's the other way to do like remote execution. There are things that don't work out of the box, so you need Docker. And I think the most important part is that not all of them are real browsers. So you can use the real Chrome and the real Edge, but Firefox is Firefox that is patched by the people from Playwright. And the thing they call Safari is not really Safari, is WebKit. And they actually patch WebKit with a lot of things that they put, and basically they put CDP inside WebKit, and then they make it work for Playwright. And that's why you need to keep your Playwright version up to date, because they connect the features you have in the framework with a specific browser version. So if at some point you stay with an old version of Playwright and want to use the latest version of Chrome, there might be issues because the protocol that is being used to connect both worlds usually works only for a few versions. On the other side, Selenide has a big community, has an open governance. Anyone can go and contribute and help. It's cross-browser, browsers that are like the real browsers your users use. You can use it in any environment, and it also has mobile. This is one thing that Playwright, I think, is trying to dismiss these days, that mobile is not a thing, but actually mobile is a very big thing. And with that, I hope I left enough time for questions, or conversations about anything. I'm here for you. if you want to chat. I don't know how many minutes we have. Do we have 10 or less? But thank you everyone for being here.
Thank you, Diego. Thank you. We have 10 minutes. So any question, please raise your hand. So we have one question in the chat.
Can we use Selenide to locate an element by its, yeah, you can do that. You can locate elements by its text, or what was the other one? By the partial text. So you can like do matches in the text as well.
It's one of the most
Thank you.
interesting frameworks that I have ever seen. Can I ask how easy is to migrate from Selenium to Selenide?
I was checking into that. I was also reading some of Andrei's comments. Well, there are basically two ways of doing it. One is replace everything, which is a lot of work, or do it slowly. Add the dependency, and anything new, you use Selenide, and when you have time, you migrate the old ones. But there is, I mean, you need to do some rewrite, yeah.
Okay.
But mostly is like deleting code and reducing the size of the assertions. And if you have page objects, then it's much easier.
Thanks. We have one more question in the chat.
Does Selenide have an embedded feature for parallel execution, similar to how WebDriver Manager handles server management? If not, are there? Yeah, I mean, I think we were talking about that in one of the last slides. Selenide runs tests in parallel by default, and there are ways to adjust and customize that configuration.
Penelope wants to ask something.
Yes. Hello. Thank you for the presentation. I just wanted to ask, you mentioned the difference of should in the weighting that the Selenide uses. So what is the main difference between should use and implicit weight? What makes it different?
So in the weight slide, you mean, right?
Yeah.
I don't know which slide was that. Let's see.
I think it
This
was
one.
this. Yeah, this one.
Well, the between which weights you said?
What's the main difference of should be visible between an implicit weight that someone could create in order to again wait for a specific time until it is visible for an element to be visible?
So the implicit weight, what it's doing, you're saying wait implicitly, I don't know, 10 seconds, and you send that command to the browser. Then you start finding elements. When the element is not found, then it's going to wait always 10 seconds for that element to be present. The wait control is being done on the browser side. So there is no way to, how can I say that, to control that, to get a better error or a better granularity in the way you control that weight. The difference with the second one, for example, is that you say wait 5 seconds until this element shows up. But what is happening internally is that every 500 milliseconds that element is being located. So there is a way that you can get that element faster, or you can actually customize how the wait is going to be done. Because it could be, for example, in the implicit wait, you could say, find this element, but the error could be anything. The reason why the element was not found could be anything. And then you cannot act on that error until you receive it back. And this is after 10 seconds. But for example, in the number 2, you can say things like, wait for this, but if this happens while I'm waiting, still try and do that. And this is the nice thing that the number 3 does, that is actually wrapping a lot of that complexity of number 2. So you can customize number 3 to look a bit like number 2 or behave like number 2, but with less code. That is kind of the...
Yeah, thank you very much for the explanation.
We have 3 questions in the chat.
Okay, this is the first one. So what is next for Selenide? Are there any coming features or enhancements? So I think, Andre, I actually don't know how to answer this question because I don't know what is next for Selenide. What is next from the Selenium project for Selenide is that we are gathering information about the most used frameworks in different languages. So yeah, Python, JavaScript, and so on. And what we're going to do is that we're going to change the website, the Selenium website, to tell people that we recommend you to use these frameworks instead of Selenium directly, because they are frameworks that will help you be a good tester instead of building your own framework. So that's what I can say about that. The second question is, can we extend the built-in timer with different values per element, or it can be extended only once for element? Yeah, no, it can be done. But you can customize it in every single wait. What I was showing basically is that sometimes people don't want to wait just 4 seconds, but just want to wait maybe 10 seconds, and 10 seconds works for every single assertion. But yeah, you can always tweak that per wait instance, let's say. And the last question was, are proxies supported for requests, either to capture a specific request or to implement a black hole technique? I've never heard that technique, but I imagine it's that you want to send all traffic to nowhere. Yeah, because Selenide is extending Selenium, and Selenium provides those functionalities. So you can intercept network, you can alter the network request, or you can just ignore the network requests. So Selenide extends all that. I didn't show those examples, but yeah, Selenide extends Selenium, which already provides those things.
Okay, any other question?
Are there more questions? No, there are more. I didn't see more. Okay. You can also mute yourself if you have a question, or if you want to ask anything else about Selenium or the WebDriver ecosystem. Like we're here 3 more minutes for you.
Diego, do you think that the frameworks that use TypeScript or JavaScript are more, how can I say, well known right now in the market than frameworks that use Java? Because, for example, I can see that most people use now TypeScript and JavaScript in their frameworks, and that's why I'm wondering why Selenide chose Java.
Well, Selenide has been there for many years. So even before the trend of JavaScript was there. So it's a mature framework, and it has always extended Selenium. So the thing is that Java was the most used language, or has been the most used language in Selenium, because that's the one that had most of the documentation, most of the resources online you could see were Java. So that's why people started to use Java. But we see that slowly languages like JavaScript and Python are also taking over for testing. And given the trend that started in the US some years ago of, like, I wouldn't say I mean, they say that's removing QA teams, but I say more like putting QA inside the teams. And there is a trend that is healthy to use the same programming language for testing as the language you're using for the web application. So it makes sense. Like if you are all programming for the web application in JavaScript or TypeScript, why wouldn't you write the tests in the same language? Then you can help each other, you can collaborate. So I think that's why all these new frameworks are emerging, because the JavaScript ecosystem changes too much and very often. And there is this opportunity for a big hype. And that's why you have Cypress that was making a big impact in that ecosystem, because it was the first big revamp of a JavaScript testing framework. Ironically, you can say that Test Cafe was already doing many things that Cypress was doing, but they didn't have the marketing money. So that's the other thing. So it's a mix of the hype and marketing money, I would say.
And I have one more question, because I saw in your slide about the water web application testing in Ruby. In one of your slides, I saw about the water testing tool,
Yeah.
web application testing in Ruby. This was my first tool that I have ever used before Selenium. I just want to ask what happened to water. Is still available?
Yeah. I mean, Tidus is still maintaining it. It's still available. The thing is that the way it's developed, you can do more Selenium releases and you don't need to update Water, because it's just abstracting what is on top of Selenium. So it's something on top of Selenium, and that makes it more it's easier to use. So it doesn't need a release every single time Selenium is released. Andre does a release every time we do Selenium release, because there is more coupling between the frameworks. So you see that in other frameworks, but in Ruby there is this opportunity to, as long as the signatures, as the method signatures don't change, there is no real need to release a new version of something.
Great. Thank you, Diego. Do you have any other questions? We have 1 minute, I guess.
We can have a photo. We can all open our cameras and maybe we can have a good photo.
Of course.
Come on, don't be shy.
I can see a lot of familiar faces. Hello, Vasily. Hello, Angeliki. Hello, Sava.
Hello, George. How are you? I'm very close to the sun, I guess.
Hello, Maria.
Hello.
Okay, so George, or are you going to count down for the photo?
Need some smiles, guys.
Some people turn on the camera, some people leave.
Okay, so 5, 4, 3, 2, 1. Great.
And
Perfect.
ready.
So thank you, Diego. Next week we are going to have
Thank
your
you.
colleague Bonnie here for the very nice presentation about comparing the testing frameworks, Selenium, Cypress, Playwright, Puppeteer, things like that. So thank you one more time. Thank you, Ilya from another company.
Thank you, Pedro.
Thank you for the invitation.
Thank you, Diego.
And see you next time. Thank you.
Thank you very much.
Thank you very much for your time.
Bye-bye. Thank you very much.
Thank you.
Bye.
Bye-bye.
Thank you. Bye.
Bye.